I'm Patrick Bailey with iQlist.com. Today is January 15th, 2019. And in this video, I'm going to be going over how to put magnets in your 3D prints without glue, just putting them in there and then 3D printing over them so they become part of your piece. Now, I've never actually done this. I've never put a magnet in a 3D print yet, so this will be my first time. But I've seen a few videos, I've seen a few tutorials, some different ideas on it. It seems like it should be pretty much straightforward. The idea is you design a void in your 3D print, and then what you do is after it creates the void, you pause your print, you put the magnet in, and then the 3D print can enclose it somehow. Just print over it and enclose it. I've never tried any of that. Also, people use that when they want to put nuts in their 3D print, and I've never tried that either. So both seem like really cool ideas to me. But anyway, I've wanted to do this for a long time, so let's go over what I'm going to try to do. So first, here's what I bought. So I actually bought some smaller magnets, but these are the big ones I'm going to try first. Got them on Amazon, $10 for a pack of 6. There might be some cheaper options, but I want a really powerful magnet. And I don't know if that's going to show up on screen. This one's pretty powerful. In fact, by chance, I'm working on another experiment, which I may do a video on at some point, where I'm putting a little screw top lid, and this actually happens to fit in this just perfectly, and magnet's on just fine. And that's kind of what I want, except for I want to enclose it, so it's part of it and it's not going to fall out. So that's kind of my goal. So there's my thought process. So, $10 for 6, so they're almost $2 a piece at this size. Really powerful magnet. So let's go to testing. I want to set up some tests so that I can get this accurate and not fail my first time. Okay, I think one of the first things you should do is do some test pieces to try to figure out what is the best size for it to, in this case, a cylinder to go drop down into. So I'm not even getting up to the point of covering it over. I just want to see what size should fit in. So what I'm going to do is I'm going to create a test piece not unlike this, where I have a bunch of different circle sizes. And here I've actually got the actual millimeters on them. But in this case, they're going to be enclosed on the bottom, and they're going to be much bigger. And so this might actually be a good size, but it wiggles slightly. That might be as best I can do, but my idea is I want to get it as tight as possible without having to really press it in. And so we'll see what we can do on that. So with that, we'll get going. So the first thing I'm going to do is measure this thing. So I measured it, and it's hard to measure something that's magnetic. But when I did some measurements, it says 1.26 inches, which is 32 millimeters. But it's not quite that size. So what did I get here? I got 1.242 inches in diameter. So it's 31.5 millimeters in diameter roughly. But I'm going to go a little higher and a little lower. So what I'm going to do is I'm going to start with 31.5 millimeters, then 32, 32.5, and so on, and get all these holes going. Also, I don't need to make it too deep. It's 0.123 millimeters. So I don't have to make it very deep. So with that, let me get going. So first, here I am in Fusion 360. So I would suggest using something like Fusion 360, which is free. Let me go to my preferences here. One thing before I start off is I like to have the Z-axis up, which is not the default. If you don't have Z-axis up, you have to reorient your drawing. I don't like that. So you can go into preferences, and you can go into, I'm going to mess it up, right? General, there we go. There we go. Default modeling orientation, Z up. So if you don't have Z up, you probably want Z up if you're doing a lot of 3D prints. Hit OK. So here we go. We'll show the origin. I'm going to right click on this and make a new component. And I'll call it magnet test. Magnet test. Boom. Show the origin on that. Right click on here. Oops. Need to show my plane here. Layout grid. There we go. Right click on this plane and create a sketch. And so what do I want? So 1, 2, 3. I got 6 sizes I want to make. They're roughly 30 a piece. So I could probably do a grid. Do 3 across and do a 3 across. So let me see what I can do. So I'll hit the S key, bring up my tools. And I want to make a rectangle. So I'll choose a 2-point rectangle. Click on that. And then go across. And now I can enter in information here. So I know worst case, I'm 34 millimeters, so I'll just say 38 times 2 you can actually do math here, which is kind of cool. 38 times 2. And then hit tab, go to the next one, and say 38 times 3. And so that should give me a grid that I think will be adequate. And then now I can go in here and start making some circles. So I'll go down here, maybe I'll make a guideline first. Hit the L key for a line, and go across. Boom, hit escape, hit L again, and I'll make another one, so I'm making 2 rows. Hit escape, and where are my tools? Okay, I lost my tools. Oh, hiding over here. There we go. I'm going to make these lines construction lines, so they're not going to, so I can use them, but they're not going to show up when I try to push and pull things. And I may have to adjust them, so let me see. Hit the D key for dimensions, I believe. Click on those 2. There, and so 38, roughly 20, so I'll say 20. And I'll do the same thing here. 20. Maybe 22. Well, we'll see what that. Okay, so first one, I hit S, and I'll use my circle with inner diameter. Click here. My first one is going to be 31.5 millimeters, and hit enter. And I'll move that a little bit over. And then I'll do this again. So the next one's going to be 32 millimeters. Oh, there we go. I can probably draw a line center to center. Oh, horrible. Line. There we go. That little triangle should mean the center of that line. And then go to the center of that line, which gives me a straight line. And then I'll make this line up there. Nice. S key again, circle. 32, 33. Boom. That makes me think I may have to make this bigger. Let me go up to the upper line and make another circle. 33. Oh, I did 31, 32. Oh, that should be 33. That should be 32.5. 33.5. Oh, apparently I am bad at math. Let's see. 34. Okay, so that's roughly all my circles. I want to line them up so they look nice. So I'll do a line across here, line across here, do dimension there. 22. Escape. Line that up. Line that up. Yeah, little problem there. So that works out. But I can need to make things bigger, right? So I'll say 42. And let's see, make that 42 too. Okay, but I still need to write on these. So let me increase this to 29 and do, let's say 90. 95. 100. There we go. Because I'm going to want to write on these and actually put the numbers underneath them so I can actually tell what they are after the fact. Let me make that a construction line. Make that a construction line. Okay, good. So there we go. Okay, so let me use my press pull tool. So I'll select everything actually. Hold the shift key down, select all this stuff, press Q for the press pull tool. And I don't need to go up high. Even 5 millimeters is overkill. So we'll go up, yeah, I'll go up 5. 5 is fine. And then I will hide that body, bring back the sketch, because I now need to make the voids. Select all these, select all these. Press Q for the press pull tool. Click on here to bring the bodies back. And then what I can do is first I want to have an offset because I want that bottom to be solid. So I'll say offset, and I'll say 2 millimeters. And then I can say to an object, and I can click the top of this, hit OK. And now, let me remove my sketch for a second. There we go, I got all my drop-in examples. And so let me bring my sketch back. Oh, no. Bring the sketch back, remove the bodies. Okay, so now let me put the numbers in there. So I will remove the sketch, click on the top, right click on the top and say create a sketch. So I'm creating a sketch on this plane now. And now I just want to put the numbers in. So hit the S key for my shortcut and select a text and start typing in here. So 31.5. I love how it's always upside down, which to me seems very weird. And I'll say bold, and I'll just put it right there. And then I'll just keep doing that. So 31.5, 32.0, bold, maybe. Okay, now I need to kind of clean them up and line them up. So I'll press the line tool, and let's see. Yeah, I'll do probably, I'll line them at the top. Go line across. Do the same thing up here. Line across. And then I should be able to, oh, you want to snap on there, don't you? I can select that line and say coincidental with that. No. Collinear. No. So I say that is collinear with that. Opposite, sorry. That, collinear, that. Well, force it. Okay, and that is collinear with that one. That is collinear with that one. And do the same thing up here. Not perfect here, huh? But it's only a test sample. It's only for testing. Okay, get those kind of nice looking. Then select them all. Q for press pull and go down, I don't know, -2. And cut. I didn't like that for some reason. There we go. -2. Bam. Okay. Let me save this. Magnet test 1. Then select this whole thing and say make a 3D print. Hit OK. And let's see. Need to make a new folder here. So first attempt, so I'll say attempt 1, and I'll say diameter test. There we go. So now, let me see if I can bring it up. Oh, I was doing some other testing today. Okay, there's the magnet test, diameter test, drop it in. Doesn't need to be detailed, so I'll do 0.2 and generate. Looks good. I'll save that G code and okay, now let me go print this out and have my first test. Okay, so I got this test printed out, this test print. There it all is. And did a few tests to see, I mean, the idea is how snug can I get it reasonably? So, at 33, it's got a little bit of wiggle there. But actually, it turns out if I go all the way down to 31.5, I can get it in there. If I just smush a little bit, press it in, it gets in there and it's pretty flush. So in this case, I'm going to go with 31.5. I guess the plastic has enough give that I can push it in there and it works just fine. And also, this is, let me see, 3 millimeters high, if I remember how I did it. And it turns out this thing is 3 millimeters thick and it looks pretty flush. I was going to do some tests on how high you need to get it, but I think I just lucked out and this actually, I think, shows that 3 millimeters is going to work. So I don't have to put those kind of tests together. But the next test that I did put together, which I'll show what I designed here. One thing. See, I'm trying to smack this out. That I learned in this test is I should have put a smaller hole inside of each one so I can more easily push those things out. Didn't think about that. If I had to redesign it and do this again, little hole to push out. But then what I did next is I designed this, and I got a bunch of them right here. And so this one, I did put the size of the hole, and then I'm testing the thickness from the base. I mean, how thick can I go from the bottom that'll work well? Because as the magnet gets further and further away from the metal, it gets weaker and weaker. The pull gets weaker and weaker. So how close do you want it that's reasonable, that feels good? Also, I made this 10 millimeters high. And I did that so it's a decent gripping thing, so I can easily grip it and test it as I pull it off of the fridge or anything magnetic. So that was my test mode, testing rig, whatever you want to call it. But what I did is I did a little mistake because in this test I'm not testing the diameter, I'm testing the thickness. But what I did stupidly is I made a hole set where it is 31.5, that tight diameter, and it turns out it kind of starts to work, and I can press it in, but once I start going deeper and deeper, it's harder and harder to press it in. So to actually get it all the way down I probably could, but it's a chore, and that's not what I'm testing anyway with this device. So I redesigned it slightly and made it 33, so it's nice and loosey-goosey, and then they just go right in there, because I'm testing the depth, not the diameter. And so I went from 0.2 all the way to 2.0. So I did 0.2, 0.4, 0.6. And let's see if we can show on the board. This is magnetic whiteboard. They're working pretty good. Also over here. So I put a bunch together, took them downstairs, put them on the fridge, had my wife test them. And of course, 0.2, let's see, they kind of jump around if you're not careful. Let's see. Where's my 2.0? Of course, 0.2 is going to have a lot more pull than 2.0. But unfortunately, 0.2 is kind of thin. And I'm afraid that 0.2, over time, I'm pretty sure it's going to break. So 1.0 seemed pretty good. 2.0 seemed just fine. So for now, I'm going to go with 2.0. But your mileage may vary. It also depends on what magnet you're using. So you can go look at the pull strength, a different thing, and debate about it. I would say 1.0 to 2.0 is probably a good idea, but hey, go print some tests out and see what you want on yours. Okay, so with that, what I'm going to do next is I'm actually going to do my next test. And my next test is I want to actually cover the print. So once, get it to a certain height, stop it, put the magnet in, and then start to print over it and enclose it all. So if I go back over here, I can probably do a measurement just to make sure. Inspect, measure that and that. Where'd you go? Go over here, 3.0 millimeters. So it is 3.0 millimeters. Just want to double check that. So let me go over here and make a new design. I'll say new component. I'll call this magnet. Magnet overlay test, I guess. Test. And I'll just do a real quick design. Doesn't have to be fancy. So I'll right click on there, create a sketch. I'll make a circle. And so my inner circle I want to be 31.5. So that's the one that worked right there, 31.5. Hit enter, locks it in. There's my inner circle. And then for this, I don't really care too much about it. I can make a square, simple enough. So I'll do a center rectangle, start there. And it doesn't need to be too much bigger. Let's say about 35. And we go 40. No, not that much. 40. 40, and I'll make it wider. 40 and 50. Boom, there we go. And then I just have to take this, hit my press pull tool, and go up, what did I say, 2 millimeters. Yeah, I gotta bring back my sketch, and then press this one and say Q, and do, so I got 2 millimeters to get there. Then I have a 3 millimeter void, so up to 5. And then I want at least 2 above that. So 2, 5, 6, 7. I want to go at least 7 millimeters there. And then now I also need to make my void. So let me back up. So I will remove my body so I no longer see it just for a second. Press on that. Press Q for a press pull tool. And what you can do in a press pull tool is you can do an offset start. So I'll start on an offset plane. That offset plane will be 2, 3, 5 millimeters high. So I'll do 5 millimeters high. Oh, wait. Nope, get it wrong. Choose that and that. There we go. Q, offset plane, 5 millimeters, and we want it to be 2 millimeters thick. And then bring the bodies back so we can see it, and make sure it's a join. Boom. So if I remove my sketches, I should just see a square. And so what I can do to make sure things are okay, I can hit my inspect here and do a, where are you? And my brain's not a measure, it's a sectional analysis. There we go, sectional analysis. And I can just choose any side like this. And then I can start to bring it back, and we can see there is my void. So, perfect. I think I got it. So now I will make this into a 3D print. Select that. Hit OK. And go to my magnet testing. I'll call it attempt 4. Oh, wait. Back up one second. Back up a second. So that's 7 millimeters high. I probably want a little bit higher because I kind of like having at least 10 millimeters to grab onto. So I can go edit. I can go right click on this, edit that feature, that pull that I just did. And so I have 2, 3, 5, and then I added, so I need to have 5. So I offset by 5, I add 5, that should give me 10 millimeters total. Perfect. Now let me inspect. I just did it, didn't I? Inspect a sectional analysis. Pull that back. Hit OK. And I actually can do do a measure, let's see. I can say inspect, measure, that line, and that line. And we have 3 millimeters, so I think we're good to go. I hit close. I will turn off the analysis. Make 3D print. Click that. Hit OK. There we go. Tent 4. And we'll call it in closed magnet test. Then I will go and bring in my Prusa control and slice it. Let's see. Parents. There we go. Really complex design. 0.2 millimeters should be fine. And hit generate. And then we got We're up to 1.0. We're up to 2.0. And then I should have a void. And I should have a void all the way to 5. Yeah, so 5 is a void. And start trying at 5.2. I have to think about that. Let me see. So 2 is the last one. And 5 is empty. 5.2 will be 0.2 millimeters higher. I may have to trick it. But hey, this is my test. Maybe I'll just test this because actually that should be, that'll give it more of a gap. Really, I just want to worry if it's going to rattle. So, well, I'll give this a test. So 5.2, it'll be 0.2 millimeters higher. So let me save this G-code off. Save. And then I probably want to do another test because I need to trick it. So if I'm going to trick it, I want to make this offset. Rather than going 5, if I go 4.9 and then 5.1, that should work, I think. So I think I'll try both. Enclosed magnet, tighter fit. That should be a tighter fit. I think that should work. Okay, so get all the way to 2.0. So 2.0 is last layer. Now we got a void. And I really want to start my next layer at 5. Oh, there we go. So I tricked it. So here at 5, I will say right when you start, put in a filament change. And so it should stop right at 5 and do that. So I'll save this off. Tighter fit. But actually, that reminds me, I messed up the other one. Let me go back, wipe that out. Maybe I'll just do them both at the same time. So I'll do them both. Maybe I'll do them both at the same time and we'll see what the results are. Okay, so do that. 0.2, generate. Both start there. And I have to put a change point there. And then one there. Okay. Okay, let me save the G code. Both at the same time. And let's go print it and see how well it works. Okay, this worked kind of brilliantly. This was awesome. So I got to this point. Here's a still shot that I took while it was going. So at this point it stopped. I put the magnet on the one side that was going to start layering over it, and then let it layer over. And then I did the same when it stopped the next layer. I stopped that and put the magnet on the other side and let it go. And here's a shot where it actually has covered up the other side. So that shot right there is the one where it actually started at 5.2, not 5.0. At 5.0, it got a little ugly, a little dirty looking, but it worked just fine. So both of them worked just fine. And then when I actually got them done, I got both of them here, wiggling and jostling. There is no wiggling or jostling inside. So I would say don't worry about the void size where you have that little extra bit. I would just say make the void 3 millimeters. And if it happens to start at 5.1 or 5.2, no problem. It just works. It just works great. So here I've got these two examples. Both the same. So here I've got 10 pieces of paper on a magnetic whiteboard, which is not all that strong. And it can't quite hold 10. But if I go down to, let's go down to 7. So here's 7 regular pieces of paper. And it can hold it just fine. But once I got these done and started feeling them, I realized the way I like it, I like a little more strength. So I did another one where it's only 1 millimeter thick on the bottom. And so here we are back on 10 pages. And this should be able to, there we go, holding 10 pages with a 1.0 millimeter. And I think you could go a little thinner if you wanted to. So it's a matter of what you want that pull strength to feel like. The 2 millimeter was okay, but I kind of prefer this 1.0 millimeter. And it worked great. So now I took a video while it was actually printing, so I'm going to kind of go over that now and explain what was happening. If I can actually get to play here. So here we are. So here I am sticking the magnet on. And so all I had to do is carefully, put it in there and then push it down. I had to push it kind of down, kind of hard, but what I didn't want to do was accidentally jiggle the whole thing, and I didn't. So I didn't actually miss a line or move it. Not a problem. Put it down. And then restarted everything. And there we go. Now it's actually starting to cover the magnet up. And it worked. There was no clicks, no grind, no hits. It seemed to work just fine. And so it takes a little bit here, but then it covers it up. And it worked. First time out of the gate, and it worked. So I'm pretty happy with it. And there we go. So you can see it's a little ugly. But it worked. But with that, I would prefer, I think the way to go is not worry about it and actually have a little clearance, because the little clearance actually seemed to look a little cleaner. In fact, let me see if I can do a video on that, because I took a video. So there we go. I've already pushed in the magnet on this one, and I'm just letting it go. And there it goes. It's covering it up. It worked. It worked first time out of the gate. Okay, so there you go. So it all worked. The only thing for me is I wanted to go to the 1 millimeter because of the pull strength, and I like that. So pretty cool stuff. In fact, I've been making other magnets now. So one thing, let's see if I can pull it up here. I'll show. Where'd you go? There we go. For those who may have seen this before, I've done a little tiny, I'm calling it decal. I did a weeping angel. So it's really, really thin, layer by layer, changing the colors out. And it's a little cool thing. So I went and redid that in a much larger size. And let me show you what's going on here. So I have made this guy, and he's actually right here, magnetized. And what I did is I put 2 magnetic voids in here. Let's see if you can see them. There you go. One at the bottom, one at the top. Did the same thing, put the magnets in here, and for the moment, I like 10 millimeters of thickness seems to be kind of the right, nice size to grip. I mean, you could go a little lower, but I kind of like that right now, and it's working pretty. I like it. I'm liking this magnet stuff. So, I guess next I'll kind of go over some final thoughts. Okay, some final thoughts. First, a little word of warning. So I got a little nervous thinking, okay, how hot can you get these magnets before they start to demagnetize? Because I know if you heat a magnet up a lot, it will demagnetize. So over at KG Magnetics, and I'll put a link to this in the show notes, they have all kinds of details on magnets. And in this case, these are neodymium magnets, so they're N magnets, but also there's different ratings for N magnets that are can handle hotter temperatures. And so with PLA, I don't think there's an issue. I think there's no problem because the maximum operating temperature is 80 degrees Celsius. Now, the bed, what's the bed on PLA? I'm doing one right now. Is 60 degrees Celsius, so nowhere near there. And also, you're not actually on the bed, you're a little above it, so the temperature is probably a little lower, even just being 1 millimeter away. So I think you're okay there. And then the nozzle is probably far enough away and so small and air's blowing on it that there's no real effect, even though that temperature is much higher. So if you're over this temperature, you will start to lose magnetism over time. There's always also this Curie temperature. If you reach that temperature, you lose all magnetism. So that's a much higher number, so I don't think there's any worry there. But there may be an issue, and I'm not doing this myself, if you're using PET. If you're using PETG or something like that, where the bed is 90 degrees C, which is more than 80, you might demagnetize it or start to demagnetize it. So I don't know. If I were doing if I was going to do some PET, I would probably do 2 prints. I would do one in PLA and one in PETG, and then test them afterwards. See if there is any difference. Maybe there's a little loss. It's acceptable because it's not much. There's not much between 80 to 90 degrees, and maybe you're high enough. It's not an issue. It may not be an issue at all, or you may just lose a little bit. I just want to put that word of warning out there, potential warning. But then with that, magnets. So I looked up. So this is a little pricey. So it's not bad. But the one I bought was roughly $10, comes up to about $1.58 per magnet delivered. And I couldn't be happier, but I was kind of trying to see what else out there is cheaper. On Amazon, I did find this. So looks like it's the same magnet, but it's a 12-piece. So if you're going to use the same magnet I use, probably go on Amazon and search around, and maybe you can, if you want to buy more bulk, I did find some 20-piece ones, but they were unavailable, so maybe you can get it down lower. This one I think is $1. Yeah, there you go, $1.12 per item, so it's a little cheaper. So, but then one thing I think I'm going to go try next is the same people I bought this from have a 20-pack, but this 20-pack is not the same. It's actually 1 millimeter thinner. And so rather than being 3 millimeters, it's 2 millimeters. I do a little redesign, but it's also weaker because it's a weaker size. So if you scroll down here in their description, this says it can hold 12 pounds per magnet with direct touch. The same seller with the thicker magnet says 18 pounds per touch. So you can actually go get a magnetic equation because the closer you are, I think it's force divided by r squared, distance squared. So the closer you are, the magnetic pull increases. So I may be wrong on my equation, but what I did a rough calculation, if a distance of 1.0 works for me, with the 3 millimeter one that can hold 18 pounds, then if I buy the 2 millimeter that can hold 12 pounds, rather than being 1 millimeter away, I could do 0.8 millimeters away and get the same exact effect. And for me, I don't need the extra weight per se, so I think I'm going to try this and do a redesign. And 0.8 millimeters seems like an acceptable strength and length and width, so I think I'm going to try that next. And report back at some point if it works. But anyway, man, this is cool. I love this. My wife's loving it because now she's got some nice magnets on the fridge that are powerful, can actually hold some things up that she wants. I like powerful magnets. Whenever I go, up in the mountains or go someplace touristy where they're selling magnets, they would sell me so many more magnets if they actually made them powerful. Because every time I'm testing, I'm like, oh, it's a cool magnet. I want that. And you're like, oh, it's wussy. So people who are selling those magnets, just make them 3 times more powerful and I would buy them. But hey, I can make my own now. So if you like what I designed and you're going to use these same magnets, just use the same measurements I did in your design and stick them in and life goes on. But if not, I hope this video helped you out. So when you get your own magnets of your own side, you have some hints to a few tips to help you get your own job done. So anyway, enough of this video. Hey, if you liked the video, please give it a thumbs up. If you didn't, hey, give it a thumbs down. Also, if you like what we were doing here, subscribe to the channel by clicking the subscribe button. And lastly, have a piece of info to share? Just post a comment.